Welcome. We are now doing laboratory experiment number 1, arithmetic of matrices using MatLab. So this activity will allow the student to implement arithmetic of matrices using MatLab, Freemat, Mathematica, or similar software. The objectives of this laboratory experiment is we are expected to be able to construct a function script using MATLAB or similar software, demonstrate our understanding in arithmetic of matrices and determinants, and then to understand and implement arithmetic of matrices and determinants using software. The materials needed would be MATLAB, Freemat, Mathematica, or similar software. Okay, we are now starting our experiment number 1 using our Freemat version 4.2. This is the first time I'm going to use this program, so let's start. We go to the procedures now. Okay, number 1, we create a 3x3 matrix and demonstrate the following operations: the common operators, exponentiation, positive and negative, together with extraction of root, negation, multiplication and division, addition and subtraction. We are going to use two non-identical matrices for operations which needs to utilize it. Okay. So we set our first matrix. So A is equal to colon, comma, 2, 3, 1, the random number there, then semicolon. You could also use space after entering each of your elements, and then you close off with a semicolon to place a negative number here. Close the syntax, press enter. We now have a 3x3 matrix. So the first one, we are going to do an exponentiation, which has a syntax of it's wise to use since we are using our program for the first time, you could always refer to the documentation. So as you can see in the history, I've been practicing quite a bit. So the first one is exponentiation, which calculates e to the power of a for a square. The syntax is expm and then your matrix. Internally, expm is mapped to a simple e to the a power expression, which in turn uses the eigenvalue expansion of a to compute the exponential. So we use this syntax expm, then set our matrix A, press enter. Here's your answer. Then next one, we are going to negate the matrix. We just simply put a negative side and then the letter of your matrix and press enter. Oh, sorry. Press enter. So as you can see, positive numbers now has negative signs. So the next one, we are going to use simple arithmetic procedures. So we are going to set our matrix B. So again, we input matrix B is equal to 1, 2, 3, 1, going to use exactly the same matrix. Close our syntax, press enter. Now we have matrix B. So to perform simple arithmetic operation on matrices, we just put in A plus B for addition, get an answer, A minus B, press enter, A times B, press enter, A divided by B, press enter. Okay, on to next procedure. Using a 3x3 matrix, compute its determinant using the formula by assigning variables to elements of matrices along its value in the most efficient way. Okay. To use a determinant, again, we are going to refer to our Freemat manual. Okay, the syntax is y is equal to det, and then your matrix, where A is a square matrix. Okay. Okay, let's set it on here, det, and then your matrix A, get an answer of 14. Det, matrix B, 14. You could also use a random number. Let's say we set another matrix C is equal to rand a 3x3 matrix 3, comma 3, press enter. Okay, we get this value. Could get the determinant now to C. Okay, so we just performed our experiment on Freemat. As we progressed in our course, we could master this software through practice. So, on to questions. Okay, on to questions. Question 1. What error appears when you try to add and subtract matrices with unequal sizes? It says error size mismatch in arguments to binary operator. Question 2. How will you stop the matrices from displaying its content prior to the operation? Simply type the set matrices, matrix letters before pressing the enter key. Question 3. What other implementation aside from one you created in your script to form a column vector, row vector, and matrices? To create a row vector, this is a 1 by n matrix. You just put a comma or a space on each of the elements that you enter, and you end it with a semicolon. To create a column vector, it is n by 1 matrix. You just put a semicolon on each of the numbers on your matrix. Another script I learned for matrix operations, the transpose, which performs a non-conjugate transpose of a matrix. The syntax for its use is y is equal to transpose then your matrix. Okay, question 4. Demonstrate the difference between a times a and a to the power of 2 and a dot to the power of 2. As you can see, a times a is it performs a multiplication of the matrix or square matrix, and then on a to the power 2 is a power operation, and a dot 2 is it raises the numerical value of an array to another element-wise. Question 5. What can you conclude to this activity? That Freemat is a powerful software that can solve matrix problems and can also be used in multiple operations for learning numerical methods. Thank you for watching this video. I hope you learned something, and as we progress, we are going to try and master Freemat. Thank you.